Hi math lovers, welcome to notes number 133. Today we're going to work with two variable linear systems. All the problems we're going to work with today are linear. That means everything is a line. So if you think about it, before we get going, there are three different kinds of linear systems we can have. We can have two lines that are parallel that never ever intersect. In this case, I will have zero solutions. Zero solutions, and those lines are parallel. So remember, they will have the same slope. I didn't leave myself much room here, huh? Same slope. I could have intersecting lines, which in this case, they intersect in one place, and they'll have one solution. Now, I have a feeling that when you did problems in Algebra 1, you had tons and tons of these, all right, intersecting in just one location. And then you could have two that are right on top of each other. They're the same line. So you'll have infinitely many solutions because they are on the same line, right? Okay, those pretty exciting, pretty exciting, and that would be some of our focus that we look at today. So I have two systems of equations for us to look at. You can use any method, really. You can use any method. You can use substitution, you can use graphing, you can use linear combination. Back in the day, that's what we called it, linear combination. Your book calls it elimination. In Algebra 1, I think your book calls it multiplication or addition or subtraction, so different methods. Okay, but I'm staring at number 15. I'm letting it talk to me. I'm thinking how nice it would be if there were a 3 right here, right? If I had a 3 right here, I could add those two up and it would disappear. So let me rewrite that first equation exactly the same way. Just copy it. And the second equation, let me go ahead and multiply everything through by 3. Okay, so I'm going to show my reader, hey, I'm going to multiply this whole one by 3. So I've got 3 times 3x, which is 9x. 3 times minus y is minus 3y. And 3 times 5, that gives me the 15 that I wanted. Now I'm ready to go ahead and add my two equations together. Personally, if I'm going to subtract, I like to multiply by a negative and then add the two together. I'm not really good with negative signs. I tend to lose them. Pachoo! There it is. It's like I meant for that to happen, right? So I have 14x is equal to 6 plus 15 gives me the 21. Divide both sides by 14. So I have x is equal to 21 over 14. Or you math lovers, I know you. Right away you see that's divisible by 7. So that is 3/2. Okay, so we got a fraction. Awesome. Let's take that. X is equal to 3/2. And we'll substitute it into either one of the equations. I don't know. I'm thinking maybe the first one. I don't know. For kicks, you get to pick. I'm picking the first one. 5x plus 3y is equal to 6. So I'm going to put that 3/2 right in for that x value. So I have 5 times 3/2 plus 3y equals 6. So that's going to give me 15 over 2 plus 3y equals 6. I move it all around and I come up with y is equal to negative 1/2. All right, so my ordered pair is 3/2, comma, negative 1/2. All right, so make sure you write it as an ordered pair because that's the way your reader is going to want to see it, okay, as an ordered pair. I have a second system for us to look at over here. Our second system that we're going to work with has, notice I'm staring at it, I'm letting it talk to me. Nothing's going to add up immediately, but I'm thinking if I multiply the first equation by 4, what would happen if I multiplied that first equation by 4? I would have negative 20x plus 24y equals negative 12. Let's keep the second equation exactly as is. Again, this is an important step. Writing this all out with the multiplication of 4 is really helpful to your reader so that you can go ahead and know exactly what the steps are that someone is using to get that answer. So right away, we're going to go ahead and add up. Okay, pachoo, pachoo. Oh, isn't this great? Uh-oh, everything fell out. So I'm going to have 0 is equal to 0. Hey, that's a true sentence, isn't it? So because it's true, there are infinitely many solutions. All right, so now I need to tell my reader. Now, back in Algebra 1, this is where you stopped. We are not going to stop here, okay? So what we're going to do is we're going to write our answer in terms of x and y. Now, what Ron does in the book, and if you read through the book, he says, let x equal a, right? And substitute that a back in, so he would have negative 5a plus 6y equals negative 3, and then solve for a minus 3. So a is equal to negative 6y over negative 5 minus 3 over negative 5. Or you could, wait, did I do this wrong? I did this totally wrong. Oh my goodness. Edit that. I'll edit that out. I want to solve for y here. Oh, this is why I don't do this method. I'm going to be completely honest with you. This is why I do not do this method. I'm solving for y, so I have negative 5a over negative 6 plus 3 over negative 6 equals y. And I could say that I have the ordered pair a, comma, and then 5/6 a minus 1/2. So he's really coming up with a formula to solve that. Now, I'm going to tell you, I don't even bother with this. This is Ron. Okay, this is Ron's method. I think about this a little bit different. So I think about my original. And I've got, funny, look at my arrow. Negative 5x plus 6y equals negative 3. And this is why I kind of bobbled on this when I was going through. I'm solving for y, right? I want to know what y equals in terms of x. So why don't I just do that? So you could just divide everything through by 6 here. So I know y is equal to 5/6x minus 1/2. So my answers that I'm going to come up with are going to be x, comma, 5/6x minus 1/2. Everything is going to use that formula. So I would really prefer, oh, I lost you there, friends, okay? I would really prefer, personally, just to see it in terms of x, because sometimes solving for y is going to be faster. And so therefore, you can leave your answer in terms of y, okay? So that was two variable linear systems. Remember, you can have parallel lines, which do not have any solution, in which case, over here, if we had gotten that, it would be false, and I would abandon the problem because there would be no solution that's good for both of them. We have one solution. I gave you an example of those. And the same line, infinitely many, that's what we did over here. If I were to graph these two, they would be on top of each other. Have fun with your problem set.